Welcome, everybody. We're going to talk about CHIP-43 today. This is the meta inner puzzle spec, or also known as MIPS, that Matt Hoff, aka Quex, has written. Uh, let's just get right into it. And Matt, do you want to just describe, I guess, start out with your motivation for why you think this chip is needed? And we'll go on from there.
Sure. Yeah. So basically, as it kind of says in the abstract, right now, custody of assets, what we call inner puzzles, right, in kind of general parlance, is very lawless and very kind of just like ad hoc, right? And there's a lot of things that inner puzzles should be doing, but they don't necessarily always do it. And we've had problems internally and externally of people making puzzles that are good and do what they're supposed to be doing. They just don't do everything that they could be doing and in a way that is compatible with other kind of custodies. And also, we were eyeing support for multi-sig stuff, and we didn't have any puzzles that supported that natively at all, right? And so, one of the big asks of this framework is to make multi-sig kind of like a fundamental part of it, right? Like once you have multi-sig, then you have that's your branching to like all kinds of arbitrary custody, right? It's like it is what you need to make sure that you can do whatever you need to do with custody. So we take multi-sig instead of making it like we make a new puzzle for every kind of multi-sig type of custody. We're just making it a fundamental part of custody in general, and then you can add on top of that. So that's kind of the motivation there. Um, is trying to standardize this and make it fully featured.
All right. Do you want to talk about how it works?
Yeah. So the way that it works, it's kind of I've iterated on it a lot, and the kind of design that I settled on actually kind of mimics CLVM a lot, which I find nice. I always like when stuff mimics other stuff that we like. Um, so you basically your top level um, object is either a member puzzle, which is what we call it. There's a whole vocabulary section. Maybe we should like scroll down to that real quick as I'm doing this explanation. Um, but there is either a member puzzle, which is kind of analogous to an atom in CLVM. It's like one key or something, one key, one vault, one whatever. And it's like someone who authorizes something, right? And then your other type is your M event, which is like a cons box in CLVM. And obviously, a cons box can't be defined without atoms inside of it. So an M event has members inside of it, and it's your way of like branching the logic. So you can have one of two, two of two, three of five, whatever, right? Um, and um, and yeah, those are your two kind of top level objects. And then each of these can be applied to additional properties, one of which is a set of restrictions. And I'll probably go into more detail on that in a bit. And then one of those is a nonce. And the nonce is kind of mimicking what we do with the puzzle derivations right now in with the standard puzzle, how we have like we can derive keys, but not all custody types support that, right? Like you can't do that cryptography with uh, singleton IDs. Like it just doesn't. That's just not part of. It's not a key. It's not a BLS key. It doesn't have to support that, right? So we're making sure to make sure that there's a layer here that makes sure that all puzzles um, can have indexes of themselves so that you can, with one key, have an infinite range of puzzle hashes, just like you can with the BLS keys. We're just making sure that availability is available to all custody types. It does not have the privacy benefits that the BLS keys does, but it still has some other tangential benefits, um, like being able to namespace addresses or when you're coin splitting it makes it more easy. It makes it easier, stuff like that. So. Yeah, that's your design. So you got either a member or an MFN, and then apply to whichever one of those. It's restrictions and then a nonce. Um, and that's your tree structure, right? When you're thinking about what the custody you want, that's how you're building your tree, right? You're building it with one of those two things, putting on whatever restrictions on whatever side of the tree you want, and then whatever, index. And uh, so I guess I should jump into how the puzzle gets run after you've constructed this tree, right? So you've constructed this tree of custody of like saying that there's a one of two at the top, and then each of those one of two is a three of five or something like that, right? You build some complex tree. Now, how do you run it? And what happens is you at the top level, you give a delegated puzzle. I should explain delegated puzzles, I guess. Um, this is one of the things that's kind of lawless in the current inner puzzle landscape, which is that the way that puzzles should run is that you should give them another puzzle to run at the very end of them approving it. So it's like every puzzle that is a custody puzzle should be approving whatever the coin is about to do, right? So the coin can do anything as long as the custody puzzle approves it. In the standard puzzle, this is how it works, right? You pass a delegated puzzle, it tree hashes it, and it you sign that with your BLS key, and then as long as that AgSig checks out, then the puzzle just runs. Um, the standard puzzle doesn't have anything to do with the behavior of the coin. That's all the delegated puzzle. It's just approving that delegated puzzle. So we've kept that here because it's very handy. Um, and you basically pass that in at the top, it tree hashes it like the standard puzzle does, and then it passes that tree hash all the way down the path of the tree that you've selected to run. Um, and all of the members approve it just like the standard puzzle does, right? Like they either sign it or they assert a vault message, whatever. Um, and as long as everything is approved, they all return conditions that will land on the blockchain. Then it runs the delegated puzzle and just merges those two sets of conditions together, and that's your final set of conditions. So you got your tree, delegated puzzle goes in at the top, down the tree, make sure everything gets the chance to raise and or return conditions. All those conditions come back up, the delegated puzzle is run, and then those two condition sets are smushed together, is the short of it. Um, Again, it kind of looks like a CLVM program running that way, where you have like your delegated puzzle is your solution, you're giving it to it, and it can like feed its way down the street, right? Um, yeah, anyway. Uh, the only thing left to explain, I guess, is restrictions. So in this, in what I've specified here, right, the delegated puzzle goes in at the top, comes down, and then conditions come back up. That's two things that are passing through the tree, right? The delegated puzzle on the way down and the conditions on the way up. And so the two types of restrictions that you can have is a restriction on the delegated puzzle that's coming down. So a subtree can be restricted to only be allowed to approve even certain delegated puzzles. That's a way to add like an extra kind of you know requirement on the subtree that's not just like someone signing it. It could just be like this can only happen after, time lock is a common one, right? This can only happen after 100 blocks or whatever, right? Like it's slow, it's a slow path of the tree. And so the restriction is only going to let the delegated puzzle through if it includes logic that makes sure that it will include a time lock, right? And then like I said, delegated puzzle on the way down, and then conditions on the way up. So the other restriction is a condition validator. These in practice not very useful. I think I put this in the chip, right? Yeah, it's somewhat rare because you usually know exactly how many members are approving things when you do the custody arrangement. So, like your members pragmatically are very small, and they're like gonna return an AgSig or something like that. And there's no need to be scared of an AgSig, right? It's only when you are putting members in the tree that for some reason can return an arbitrary set of conditions that you might want to restrict them from creating side effects or something like that, like making new coins or creating announcements, et cetera, et cetera. Um, it It's just that you don't do this very much. Most of the time, your final nodes of the tree are just like very stupid little puzzles that can't do anything except return an AgSig, which is not something you need to be scared of. An AgSig or a SIR message, whatever. Um, but they're there just because they're for completeness, right? And it's not like it doesn't cost very much just to have them as a thing in there. So uh, there are very rare scenarios where they're probably useful, and they should be in here just for completeness, I think. Um, Yeah, so that's kind of the implementation rundown, I guess. That's top level. There's obviously all sorts of Chia lists to dive into if you want to, but that's the functionality of it, the design.
Yeah, that's great. Thanks. I think as far as the looking through the Chia list, people can just do that on GitHub. But yeah, it's a great overview of the chip and what it's all about. You guys have questions so far? Comments?
Um, I mean, I noticed that the way that restrictions are implemented for the delegated puzzle is that instead of reviewing like the list of conditions that it outputs, you sort of enforce that the delegated puzzle be wrapped in another program, which then does the validations that you want. Is there a reason that it was done that way instead of just having a condition validator like the member puzzle does?
Yeah. It's a little bit of a shortcoming of the framework. I think there's a section in here that says like this is very much a V1 and there are parts that could be improved. Like I'm not saying this is like the general theory to solve all theories. And I guess we should talk about extensibility at some point. But if you want to validate the conditions of the delegated puzzle for a subtree, you're going to have difficulties because the restrictions, they live in the Chia list at the subtree layer, right? So if you're like one or two, three, one or two paths down the tree, that's where the restriction lives. But the delegated puzzle conditions, like the delegated puzzle only gets run at the top. So you would have to find a way to like get those restrictions from the subtree to like apply to the conditions at the top. And there's just like there was just too much Chia Lisp involved in making that happen. And I realized there's a way you could do it, which is kind of a hack, but I mean it's got some elegance to it. It's just maybe too much elegance, too much complexity. Um, which is that instead what you do is you enforce that the delegated puzzle that's getting run has its own restriction on it that is going to make sure that any attempted conditions that are bad are going to cause a raise when the delegated puzzle is run at the top. So you're kind of sneaking it in that way by attaching it to the delegated puzzle, and that's how you get the restrictions up to the top, right? Um, because the delegated puzzle is going to get run up there. So that's kind of the approach I took. And again, it could be probably more elegant. There's probably a framework that makes it more elegant, but it's just like that disconnect between only running the delegated puzzle once, but then multiple things wanting to validate its conditions that causes the complexity there. So yes, that is one of the quirky parts of this for sure. I guess I did bring up extensibility, so let me go into that real quick. If you want to scroll to the memo spec section real quick, that's a little bit up. Yeah, yeah, there.
That's fine.
Yeah. So I think I don't know if we decided on a namespace. Maybe we should update this. I don't know if we're doing like CHIP-43 or whatever. We should double check that and fix it if not. Anyway, um, yeah. So the memo spec is its own thing. I guess I should explain it as well. But the that TBD namespace right there, which probably will say something like CHIP-43 or something, um, is basically a hook that's telling the wallet driver who's parsing this puzzle like what they're doing. And because I said this is not the end all be all. This is a V1 for sure. Um, this can change, and I wanted to make sure there was a hook in there for the wallet driver to see this and be like, I don't support this. I can't parse this, or I see this old version. I can use my old drivers, right? Instead of a lot of times our memo specs right now are very much like very minimalist, which is good for on-chain costs, obviously. But they have no hooks for if you're looking at a memo spec, you have no idea what it's a memo spec for. And so that's what this namespace is for, is to make sure that you give some signification that here is what I am like, here's the language I'm speaking, and then here's what I have to say. Um, so that's that part. And then for the memo spec in general, it was designed. It looks big, but in reality, most of them turn into nils at the end of the day. So it's kind of a big tree of nils, um, and it's designed so that you don't have to have drivers for every single node in the tree, which is an advantage from many of the puzzles nowadays, where wallets have to support all kinds of stuff and just have to keep building more and more support into wallets for it. It doesn't have to support every node in the tree, only the nodes that you intend to spend. And this memo spec is designed so that you can reconstruct the proof, the tree proof, without knowing all of the information of the individual nodes. And so as long as your wallet can handle any specific set of members, um, you can spend the coin even if you don't know what the other members are, right? Like that's what this memo spec is for. So the thing that gets the kind of question marks when someone goes over it is you get the full puzzle hash of the restrictions, and the where is it? Oh, and the full puzzle hash of the member, right? So you'd think like you'd want maybe you could get away with like a mod hash and some arguments or stuff or whatever. But if you have the full puzzle hash there, that's what allows this ability to only know some of the tree and yet spend the whole tree because the full puzzle hash is what you're going to need to make the proof. Um, so that's an optimization you might run into if you're looking over this that is specifically not taken because um, it it would ruin that functionality of wallets only being able to support like the stuff that they know.
How would a wallet that knows about, well, that tries to, let's say we have a one of n, or yeah, one of n, and my wallet is holds one of the keys. I would like to find this thing, and the hint is still just one single hash, right? How would you find that?
Yeah, so hinting here is that's a kind of a separate problem. It's not really tackled by this chip because hinting for multiple parties is hard, right? And I did not propose a solution to it in this chip. But the memo, if you once you have the coin, the memo will allow you to parse whatever spend path you have. But for hinting to like you want to get multiple people notified, it's a difficult question that we still haven't really fully answered. We kind of abstracted away by saying that most of the people are using vaults, and then therefore we're going to use the vault singleton ID, and that's how they're going to pick it up. But that requires them to know their singleton ID before they're going to pick it up. So it's a little bit of a bootstrap problem there. Um, and
Yeah, but it's
and
simple enough to just transfer that information over like this
yeah, yeah,
one launch ID. You just tell it like be it in a QR code or in some export file, whatever.
right. It's just different
Saying this is a thing.
from it's just different from like our standard XCH custody where you just have a key and that figures out the hints for you, right? Like this one you need the hint
Yeah.
beforehand before you can go do everything. Yeah.
Um, One question I have is like, do we have a place for standardizing the like the arbitrary memos for the members and restrictions? Like, if you have a time lock, for example, I'd imagine you'd want the number of seconds in that hint, but I don't think that's specified anywhere in this chip.
I mean, it's not specified per restriction, but I mean, the restriction hints there, they give you the full puzzle hash of the restriction, and then it says arbitrary memo, so they can have their own specs, right? But that's going to be its own recursion of that's going to be some other chip, some other implementation, right? Like that is a something not covered by this chip, but it can have its own, namespace hook and whatever. It can do whatever. It's just that not necessarily for the entire framework to work. Um, but but yeah, it definitely that's the hook there is that memo is arbitrary as well. So there's extensibility in that respect.
So it sounds like we could have a
You
whole bunch of chips related to this one eventually.
Maybe.
Possibly, yeah.
you only need that memo if you want to spend that thing, right? If you just want to spend another part that you don't care about, then the full puzzle hash is enough. That's the point.
Yes, correct.
Yeah, I'm just thinking it might be nice to have a maybe just another chip that has a list of those puzzles and the memos that should be used for them.
Yeah, living chip for sure. This is like good practice. This is a good vetted puzzle to use as a restriction, etc. Like that's yeah, I would have you down for that.
Yeah, that's a good idea. Then we could update it with time.
Do we have one? Is
One, sorry, go ahead.
there a framework for living chips already, or is that something we'd have to add?
Yeah, so the only living chip we have right now is chip one that describes how to do chips, but
Oh, really? I thought
um,
that was
that's the only one that's currently there that's officially we can just keep updating it. But yeah, we can do that in the future. And I do have a living chip that I want to write also anyway for something else we're working on. So
Yeah.
this could be another one for sure. Lex, one thing I was going to ask you is at what point should developers think about using this spec as far as let's say you're developing something in Chia, at what point of complexity do you go, okay, I need to use MIPS instead of just a very basic puzzle? Or should we always be using MIPS from now on?
basically I would say always use MIPS. You know, careful because like most people are not developing custody puzzles. If they're developing puzzles, I think most people are probably developing outer puzzles, which we should have a meta puzzle spec for that, but it's just harder because inner puzzles change every spend and outer puzzles can never change or mostly never change. Um, so it's less work to ship this than it is to ship a meta framework for outer puzzles. That being said, yeah, if you are developing an inner puzzle, a custody type of sorts, I would recommend making it as a member, and then a member puzzle in the spec, and then shipping that, right? Because then you can use all the wallets that use MIPS can just like plug that in, and go with it. It's the minimal amount of it's going to be the minimal amount of lift for wallets that have implemented MIPS to implement your puzzle in their wallet, because it will likely be very small. But realistically, I mean, there's only so many custody types that you can really dream up. I mean, it is technically infinite, but it gets silly at a point. So, um, uh, yeah, I mean, always use MIPS if you're developing custody. I would say, um, I don't know how common that's going to be. Um,
Yeah, fair. Do you
I
know if
guess
I
I
think
any?
guess,
we
I guess
realized that
Oh,
sorry, go ahead.
we realized that in the in developing the vaults that you can actually replace most, if not all, of the old P2 delegated puzzle or P2 singleton or whatever you want to do with this, and it's actually pretty cool.
Yeah. One thing I was going to say is that actually sometimes you do develop custody in the form of launchers, which is a type of custody. And so if you're doing anything with launchers, like I'm prototyping something right now, and I'm using a launcher for it. And uh, that will be a type of custody, and then that might be something you might want to look into using this, if that's what you're doing. It's kind of hard to explain, but that is one, I guess that I said custody is not that common, but launchers are quite common, and then they're definitely not outer puzzles. So something to look into there.
I have a good example of what can use the spec pretty nicely, even though it's not a really standard custody puzzle, which is basically a pre-split offer coin that you can either spend as part of an offer or have a separate spend path that is just like your normal wallet puzzle. So you can pre-commit a coin that is then only be able to take with an offer, or you can do whatever you want with it. And that's basically just a one of two of a P2 singleton and fixed conditions, which is pretty nice with this framework.
Yeah, exactly. Yeah, any logic splitting that you're doing like that, you're probably in custody land. You should probably be using this. Yeah, for sure.
Especially if you consider just I want this or that to spend this, and even if you have fixed conditions, which can be very different from project to project, it might just fit into this framework too.
I don't know if it was mentioned or not, but things like revocation can't use the MIPS.
Yeah, I was just gonna go on a little tangent about that. Uh, One big limitation here is that the whole feeding in the delegate puzzle thing from the top, uh, we use a specific puzzle for that. And that means that the top level basically looks a little bit different than all of the member like recursions. Um, which and I think I'm a little bit separated from it, but I'm pretty sure that was an optimization thing. I'm not entirely sure, or just like a complexity thing. It was too hard to make the puzzles work in a way that it was like uniform across the board. So anyway, it's not like you can have your member address and just kind of hand that out to people, and they can just like throw it in their trees willy-nilly. Um, it's like it does require like when you're setting up the tree, like you have to know like what their keys are, right? Like it's not like just a puzzle hash, like how we kind of do stuff now. You're setting up something that is like their keys and stuff like that. So for the revocation layer, right? Like we debated using this, but it's an arbitrary puzzle hash on one side, and that kind of breaks in MIPS because if you have it's I mean it could work, but it's not an address that anyone would know or know how to use. So that is a limitation here and something that we should, be looking to fix in a V2.
okay. Any other thoughts about this? Sounds like.
I think main aspect from my point would be to have a list of all the things that have been created already that are either members or other like DMON puzzles. I think we have that in the Chia SDK, right? Is that the only place, or do we have another one? Chia puzzles, probably, right?
Yeah, the
Yeah.
actual Lisp is in Chia puzzles waiting to be merged, and then the implementation is in the Walrus again.
Okay. So it sounds like for the spec, it's mostly done, other than um, there was this little thing to add, and
Yeah,
then
we definitely did choose something already. We just got to figure out what it was.
okay, well, whatever you go with. And then it'd be nice to have just the beginnings of that living puzzle, and then maybe we can reference it within this chip.
Or you mean, sorry, living chip, you mean?
Or sorry, I said it wrong. Living chip.
I got
Yeah.
you. Yeah, okay, gotcha. I was just making sure because you said you said the chip. Okay, yeah, okay, my bad.
It's a little late for me. Um, so yeah, we could get that in this chip, and otherwise, it sounds like we're pretty much ready to put it in review. So that can happen very shortly. If you, unless you're planning on working on more stuff on this, Matt.
No, no, this is good. I'm with it for a V1 anyway. Like I said, there's limitations that a V2 could help with.
Yeah, cool. And then for the different versions, we can just open a new chip as well, for each one, and then Waltz can reference whichever chip in here. Um, okay, if there's nothing else, we can wrap this up.
Thank you.
So thanks for joining. Please leave any questions, comments, reviews on GitHub and the PR. We're also available. I think all of us are available on Discord if you want, and there's a Chips channel there. I'll put the recording for this up on YouTube. And thanks everybody for coming.
Thanks, Dan and Matt.
Okay. Take care, everybody.
Peace.